Hi everyone, I'm Yan Yan, a production engineer at Facebook. Today I'm going to talk about machine learning artifacts ownership enforcement. Machine learning artifacts are models, features, data pipelines, code, or anything related to machine learning. Before I start, please let me introduce what is production engineering. Production engineering at Facebook is a hybrid between software and systems engineering. It keeps Facebook running smoothly and scaling efficiently. The production engineering team works with Facebook's product and infrastructure teams to make sure our services are reliable and scalable. The team writes code and debugs hard problems in live production that impact more than 2 billion people around the world. From back-end services like our Hadoop data warehouses to front-end services like messages and newsfeed to infrastructure components like our caching infrastructure, load balancing, and deployment systems. The production engineering team makes sure Facebook keeps running. I will start with a background story, followed by the problem statement, challenges, the solution workflow, architecture, and walk you through an ads example. In the end, I will share benefits, future work, and my takeaways. Let's start with a story. I was taking an on-call rotation. Everything was safe and sound. Perfect on-call experience. Until an ocean of alerts bumped into me. A bunch of high-priority tasks firing simultaneously were already scary. Not to mention, there were also many UBN tasks, which means unbreak now alarming at the same time. So I started investigating right away. I found a sharp data spike. Infra seemed pretty stable, but several production models were very abnormal. By digging into this problem, I found it was related to some features in production models. But one model uses thousands of features I was not familiar with, a completely unknown territory. I couldn't understand those alerts, so I decided to find feature owners for support. Surprisingly, this became another challenge. I found that many people had made posts to find owners before. Those answers were not very helpful. So I continued searching. And surprisingly, various owners were defined across several code bases in different programming languages. In code base 1, Alice was the owner. Oops, Alice was already an ex-employee. In code base 2, Bob was the owner. Uh-oh, guess what? Bob was on vacation. In code base 3, Chris was the owner. But Chris changed teams a long time ago. In the database, David was the owner. But David created version 1 of it just as a ramp-up task. He really didn't know much about it. Finally, I decided to make another post. Luckily, I managed to find the correct owner with the help of several other on-calls to tag and redirect between several most likely POCs. With the owner's input, the problem was solved pretty quickly. However, the process was so painful, unnecessarily long, and inefficient. I think most of us, more or less, have had similar experiences. We are faced with the problems that when on-cores handle operational machine learning issues, they may not be able to understand or troubleshoot all the problems independently. Sometimes we need machine learning artifacts owners for inputs. However, the workplace environment is highly fluid, and there are discrepancies across systems. So usually, it's very time-consuming to find reliable on-cores or owners. This not only endangers our systems, prevents us from scaling up, but also makes privacy work very challenging. Privacy is critical for machine learning. Without accurate and up-to-date machine learning artifacts ownership, it is hard to efficiently validate and keep privacy compliance along the time. Our goal is to build an organic process for self-maintainable ownership, which is consistent between systems across the company. Now, let me talk about our solution workflow for building up machine learning artifacts ownership. Our first step is forming virtual work teams because we have many product teams such as ads, Instagram, marketplace, feed, and etc. There are huge differences between these product teams. We need experts from each area to drive this effort, following a unified plan and timeline. Next, we need to identify machine learning artifacts from non-machine learning ones. One challenge we had was there were too many of them, including production, experimental, custom, and code. So step 3 is to classify these machine learning artifacts. Then we decided to gradually roll out enforcement by prioritizing production and experimental ones, followed by custom ones and all the machine learning code. For existing machine learning artifacts, ownership needs to be registered by one-time backfill. For new machine learning artifacts, ownership is enforced upon their creation. If ownership is not set, the creation of new artifacts will be blocked. However, it's not trivial to change so many machine learning engineers' behavior. We need a standard and a simple technical solution to make it happen. This is our solution architecture. One challenge we had was that different applications across product teams were using different machine learning platforms, such as FBLearnerFlow, PyTorch, and so on. It means machine learning artifacts are defined and stored in various places and ways. In order to have a company-wide machine learning artifacts ownership enforcement, we decided to use a unified data inventory, leveraging our entity framework, ANT. Under the hood, the metadata is stored in a GraphDB. ANT will create DAG between entities. As we can see in this example, each node is a machine learning artifact. It can be a model or a feature. Each edge represents the relationship between two nodes. Ownership information must be set inside every node as an attribute. Data inventory will provide APIs for product teams to read and write their machine learning artifacts together with ownership. In this way, various machine learning artifacts in different platforms can be registered and maintained in a central place. We reached our goal that all machine learning artifacts are registered in the data inventory with ownership. I was the ads POC in this effort, so let me share with you the ads use case. For ads models, we have model launcher information in machine learning platforms. But one challenge we had for production models was that model launchers may not always be the one with domain knowledge, or the one can make critical decisions for these production models. Models may be launched from scripts or platforms by identical owners or robots. The solution we took was to use model type ownership information. Model types serve as model inference purposes. Model type owners understand model serving thoroughly and are responsible for production models. For features, we were faced with the challenge that there are several feature platforms. One of them was legacy, and one of them even didn't have per feature level ownership data. For the legacy platform, we audited and filled in all missing feature ownership across ranking teams. For the platform without feature level ownership information, we managed to build feature ownership according to feature pipelines, extractors, and so on. After one-time backfilling of all existing machine learning artifacts ownership, we needed to ensure new machine learning artifacts would be created together with ownership. So, validators were created across different machine learning platforms to block creation without ownership. To keep ownership information up to date, an ownership observer was created inside of data inventory. Notifications will be triggered upon ownership updates. Users can leverage UI or APIs to update ownership easily. With ownership information, we were able to establish more metrics, build up alerting, tooling, and visualization about machine learning artifacts. Now let's see how the system will react upon what happened in the story. Observers will detect Alice left the company, Bob is on vacation, and Chris has changed the team. These owners will be automatically updated to their managers. Then managers can go to UI to set accurate owners, who are Manny, Ellie, and Frank. In this way, we can provide up-to-date and easy-maintained ownership. In the past, alerts could not be sent to right owners to take actions effectively. For example, failure alerts will be sent to Alice and Chris, but now they are sent to Manny and Frank, who are available and also have domain knowledge to troubleshoot efficiently. In this way, we could actively increase success rate and save engineering time. Also, whenever we need to apply or check any privacy policy, we can have owners' inputs and confirmation. Now on-callers are happier, as alerts are redirected to right owners directly, so they have fewer alerts to deal with. Having trustworthy ownership information is benefiting more and more other projects, such as migrations, deprecations, and so on. It's making collaborations and communication more efficient because now it's much easier to find accurate POCs to talk to. Systems are getting more reliable as we have handy ownership to investigate issues. We can scale up more steadily without privacy concerns. Now let me talk about future work. Clear ownership enables privacy review over machine learning artifacts creation. We will be able to build better infrastructure to ensure we apply new privacy policy to all the machine learning artifacts. Currently, not all machine learning artifacts are assigned with on-call rotations. They may only have owner's information. To prevent single point of failure, owners will be gradually converted to on-call rotations. Furthermore, we will work on a smarter and more automatic process to infer and maintain ownership for machine learning artifacts. Last but not the least, it is an inevitable trend that ownership enforcement will expand to cover non-machine learning artifacts as well, such as all the services and code. In the end, I would like to share my takeaways from this experience. Privacy is and should always be the first priority for machine learning. Building machine learning artifacts ownership is the first step to ensure it. However, it is very challenging to change existing systems or people's behaviors. What we can do is to build a centralized data inventory to fit all use cases. To build and store all machine learning privacy metadata, we need to standardize the end-to-end process for machine learning artifacts, from creation, training, serving to deprecation. During this process, we need to enforce ownership settings as early as possible. Privacy is Facebook's first priority all the time, and Facebook have been devoting to continuously improving privacy and security. I believe all companies using machine learning care deeply about privacy. Thus, we all need to build up machine learning ownership as the first step. Although we may use different techniques or various system architectures, the high-level idea should be similar. I hope my sharing inspires you to invest in or improve machine learning ownership enforcement, which will lead to better machine learning privacy and security. Thank you for watching and listening. If you have any other questions, feel free to send me an email at yy27@facebook.com.